Everyone. So today we will continue with our fourth chapter, which is validity of testing and measurement class. These are my notes from the slides, but also I will go through each subject very detailed, and I also have some notes from the book as well. So it's a combination of both the slides and my note from the book, and I will expand on certain things that are more important. Let's start. So firstly, what is validity? It's the degree to which evidence and theory supports interpretations of test scores and entailed by proposed uses of tests. So validity of measurement can be either based on content or construct, and validity of decision is based on criterion related validity. So let's start with the content related evidence of validity. I feel like this is the most easiest one, and I think you will understand why I think it's the easiest one, why I say this. So content of the test, it should be representative of the domain. The content it's supposed to cover. There shouldn't be any construct under representation, or there shouldn't be any irrelevant variance. We should define content domain and total set of behaviors. So for example, if we are designing a knowledge test, we should go through the textbooks, instructional materials. But if we are designing a cognitive ability test, we should, I don't like this one. Okay, I'm sorry. We should go through general specific abilities, if you want to focus on the general abilities or specific abilities. If we are creating personality construct domains, we can check definition of construct and how prior research defined it. So we just decide on broad or narrow assessments, and we can also use attitude scales, etc. So in content related evidence, what's important is that we use adequately sample behaviors or items, and we identify categories. Different items may have different importance level in our study. So we may give more detail to certain items that are more difficult. And so the third thing is they should be assessed based on personal judgments, because we cannot really use statistics when we are just deciding for the if this question, if it's related to what we are trying to measure or not. So it has to be based on personal judgments. But when we use subject matter experts, their opinions, so that's when we can make sure that it's as objective as possible. So it's most practical for knowledge tests, especially. So then secondly, so as you can see, it's we don't do a lot of statistics. We don't do any statistics, basically. It's based on personal judgments, because we can't do statistics. So that's why I said I feel this is the easiest, because it's just about not having any irrelevant information there, just how really covering the content and stuff like that, basically. So now it gets more detailed, I feel with construct related evidence of validity. So this is about test measuring hypothetical construct, the way it was designed to measure. Is it measuring hypothetical construct the way it's designed to measure? Construct, what is construct? We need to know that first. So constructs is a hypothetical abstraction of regularities in behavior or phenomena. They are related to observable behavior. They can be inferred from observable behavior. They can be related to unobservable constructs as well, which is also related to behavior. So yeah, constructs are hypothetical abstractions of regularities in behavior or phenomena. So when we are trying to get a construct related evidence of validity, the evidence is accumulation of empirical support, like different ways to support what we measure, basically. So we use convergent and discriminant relationships. When we use them, we can do different methods. We have a lot of methods, as you can see. There's multi-trait, multi-method matrix, there's nomological networks, there's contrasted groups, there is direct observation of behavior, evidence based on response processes, evidence based on internal structure. So we're going to go through all of these things, but first let's go through convergent versus discriminant relationships. So construct validity of my test of extraction. Let's give the example from this. Like I took a test of how extroverted I am. I'm trying to measure. And so we might expect strong correlation with like extroversion with with having a lot of friends, for example. So when we are expecting this, because it's something that maybe in other studies that's seen, so when we are expecting strong relationship, it's about convergent validity, whereas like for example it's something completely unrelated to extroversion. I don't know, like if I like bananas or not. So that will be about discriminant validity, because it should not, like if I'm making a test that has construct validity, then I should not find a correlation between me liking bananas and extroversion, my extroversion level. As far as we know, I don't think there's any correlation between those two items. I hope so. So multi-trait, multi-method matrix is like we are looking at multiple constructs or methods. There are different measures and they give similar results. And when they give similar results, what this means is convergent validity. And different constructs, when they have smaller correlations, this gives us discriminant validity. And in multi-trait, multi-method matrix is like we're combining those things, and we may have like method bias, which is different constructs assessed with same methods yield larger than theoretically expected correlations because of like method biases. This may happen. And if we are finding different constructs like yielding larger than theoretically expected correlations, like for example I gave the stupid example of like me liking bananas and my extroversion levels. So if I find a like correlation between them where I should not be finding any correlation, this gives me the idea that my study has a method bias. So then we also use nomological networks. They describe all associations of a construct. Like, for example, I think we will explain this in a later slide. But I want to further explain it right now, so I just took the slide that I was explaining nomological networks. It's about all associations from the item. Like for example, this is my item, right? This is me, this is my item, right? There is an antecedent, which is the reason, I guess, for my item, and there is the consequence of my item, and there is a correlation between my item and another thing. So these are the important aspects of nomological networks. There may be an antecedent, there may be correlates, and there may be a consequence. So these are the important aspects basically. And this is something that we use in construct related validity, as we have explained. Now let's continue with the we were here. Okay, So then we can also use contrasted groups for evaluating contrast validity. So with contrasted groups, we are comparing groups where we would expect differences on the construct. Like, for example, let's say that there is a math, right? We gave an example, I guess. Let's go with that one. Like, we made a math reasoning test for 5th graders. So we would obviously expect differences for 3rd graders and 4th graders in terms of like success rates. So this means that we should find some differences if we have successfully made a math reasoning test for 5th graders. So now we are just comparing those groups and we are trying to find a contrast between them. The difference, contrast, difference between them. Like, we can also give the example of, I want to, so we can give the example of basically like IQ test, for example. Oops, this doesn't work with my, none of them work. I need a different color. Okay, let's see that we are doing an IQ test. And so if we have successfully made a good IQ test, for example, then we should definitely see a difference between people who we have successfully assigned as like lower IQ levels group. Oops, why is this happening? I'm sorry, my handwriting is not very pretty. I'm sorry. So there is the lower IQ level group and there is a higher IQ level group, right? So if we have successfully made a good IQ test, then we should be able to differentiate between these two groups in the study. So that would mean that we made a test with good contrast validity. So this is basically what contrasted groups measure. So basically it's for contract validity again, and yeah, we're just contrasting between different groups, trying to see if we are successful in our measurement in the groups that we already know the scores, like the groups that we already know which group that they belong to. So yeah, I think I didn't need to write these. Oh my goodness, I didn't know I wrote these. But basically, like in levels of intelligence, or we can compare depression test scores of people who are diagnosed based on other measures. And if it's a valid test, then it should show differences effectively. Basically, that's what contrasted groups is doing for us. So we can also like directly observe their behavior, but this is not always feasible. So like for example, maybe we can do for aggression, like we can look at the test scores of school kids, and if this is like correlating with observed behavior in class. So is the test scores of like aggression correlating with their actual aggressive behaviors? So direct observation may not be helpful all the time. Then we can ask them, like we can ask the participants, like why did you make this decision, why did you choose these answers? Like we can ask them about like what they thought while choosing these things, because did they choose the options because they are genuinely in that group, or did they choose it because of different things that we didn't account for? So we can just ask the participants, I guess, and like look at their responses. So this is called evidence based on response processes. Like in a math reasoning ability test, we can ask the test takers like what they taught, what strategies they used, and yeah, here I have the same exact slide. I have explained. Okay, we went through this. Okay, so then we have conditional reasoning test of personality. Like there's two choices. There are two choices and two different personality motives. So like, why did you choose this specific option? We're looking at their responses. We're looking at why they chose this specific response, etc. So evidence based on internal structure. This is, wait, I'm sorry. Okay, so this can be done by like factor analysis. Factor analysis is used to basically summarize patterns of correlations among a large number of items and measures. So it is good for test construction, like which items go together and how many sub-factors are there. So it groups similar adjectives together. It groups unrelated adjectives in different factors. So we can see the actual correlations that we want to, like we are looking for. No, okay. So then we have criterion related validity. Our test basically should be predictive of some specified consequences, like outcomes of decisions or criteria, like SAT scores and GPA. Like we want to, like for example, we are doing a study where we are like predicting that SAT scores like predict basically they predict the GPA scores, like how good person does in the SATs, predicts their GPA score. And in intelligence test scores or job performance, yeah, we're like predicting that if they have a high IQ, that means that they will do well in their jobs. So but we need to like, so when we are doing this, we need to apply criterion related validity to make sure that we what we measure is accurate. And in criterion related validity, basically depending on predictor test, we may use other focal criteria to validate our test. And it checks if test scores can predict performance or behavior in real life like we want it to. So yeah, our test is predicting something, and then we are doing criterion related validity on it. So like for example, maybe we are measuring work discipline for academicians, and then we are looking later where we want to learn about the criterion validity of our study. So we are looking at like the publications that the academicians made in 5 years and the extra coursework that they did in these 5 years, so that we understand like if we measured their work discipline correctly. Or maybe we are doing an extroversion test, and then we are looking at like how many close friends they have, or if this is like we are measuring their extroversions for understanding like how many products they can sell in the sales. We can like check how successful they will be in sales. We can check like how many products they sold. And in antisocial personality test, like theft, drug use, unsafe sexual behavior, etc. So these are like similar examples basically. So what we're looking for is basically can the predictor test really predict, and then we are asking these questions, we're checking for these questions to make sure that we have successfully found something. Yeah, and this is related to criterion-related validity. So here we have talked about this, but in the slides this was mentioned again, so I wrote this again here. It's basically nomological networks. We have talked about this earlier. So nomological network describes all theoretical association of a construct with antecedents, correlates, and consequences. As we said earlier, antecedents is what causes our item, and correlates is what is correlating with our item, what is related to our item, and consequences what our item predicts. So it helps to determine whether a construct behaves as expected within a web of related variables. It supports construct validity. And we have, again, in criterion related validity, we are proposing important in selecting criterion, and a test valid for one criterion may not be for others, so we need to check for each criterions basically. Now I said this sentence wrong, I think. Our purpose is important in selecting criterion. I'm sorry. So how to study criterion related validation? We have two strategies. So the first one is predictive, and using predictive method, and then the second one is concurrent. So when we use predictive, it's basically like we measure, like for example, we want to know if SAT scores will really have an effect on their their GPA scores, right? Then we obtain test scores at time 1 before making decision. Like we look at their SAT scores, then we look at the same people's like GPA scores like 1 year later in freshman years. It's ideal, obviously, because we can genuinely see if it's predicting or not, but it's impractical because it's gonna take a very, very long time. So what we can do instead is concurrent strategy, and in this strategy we don't need to wait a year. We can just like obtain test scores and assess criterion at the same time from pre-selected sample. So it's practical, and its nature of selected people nature of selected people may not resemble nature of applicant population. Like for example, like when we are looking for like people, let's say their IQ levels and how it correlates with how successful they will be in the job that they do. But let's say that we already like hired the high IQ people, but we don't know like low IQ people if they will be successful or not. We only collected data from high IQ people and how successful they are in the work environment, but we don't have enough variability in our scores to conclude something. So that is one issue about both of these tests. There is an issue, but especially in concurrent strategy. So problems with criterion related validity, because there are quite a few problems. So first off, I have mentioned this just now, the range restriction on predictor. Because we only hired like high scorers, now we can only analyze the high scorers, but range of scores are too narrow and little variation to analyze. So what happens is that, let's continue with the items. So like range restriction on criterion, use selection and attrition. Attrition, I did not remember this. Attrition is basically like who drops out of the study, and the people that we select are already like the people that are like working in that job, for example. So there's quite of a range restriction if you come to think of it, and criterion is the outcome variable. range restriction can also occur on criterion because of selection or attrition, like who gets included and who drops out. So as I explained earlier, if only high-performing employees stay in the company, there will be less variability in performance scores, and this will reduce our observed correlation. So effects on range restriction, both forms on predictor and criterion reduce correlation between the test and the criterion, making tests look less valid than it is. Statistical corrections for range restriction on predictor to estimate true unrestricted correlation we can use. We can use statistical corrections for range restriction. Then our another problem, conceptual problem. Sample is selected, so it's hard to detect potential failures of the test. And we might overlook cases where test doesn't work well, sample doesn't represent full population. So we may just look at how successful our test is because we hired these people that already did very well in their test and they're doing well on their jobs. But maybe if we hired people that did not as much as good, maybe moderately good, but they were also going to be very, very good at their jobs or maybe even better than them. So we don't really know if the test is measuring well. So we need to look at everyone. So in meta-analysis, we can look at overall estimates between predictor and criterion. Meta-analysis is another step after we have done our criterion assessment. We look at overall estimate between predictor and the criterion, and from correlations from several studies we weight based on sample size. For example, a study that is done in a very small sample size, we may not really want to use that data, and at least base our research just on that study. Maybe if there is a study that is done with a larger group of people, so it's way more reliable, then we would use that one more, the results of that one. So we just weight them based on the sample size. That's what it means. And it's corrected for test unreliability, attenuation is test unreliability. Basically, we will explain this in a couple of slides, I think. And it's corrected for range restriction. We have talked about range restriction, how we are just looking at, for example, the people that got hired, but that is creating a huge range restriction for us. So researchers gathered correlation coefficients between predictor and criterion from many independent studies, and then we create something called meta-analysis, basically. Studies with larger samples, more weights, we have talked about this. So this avoids small, less reliable studies from having too much influence. And if predictor or criterion measures are not perfectly reliable, then our observed correlations will be lower than the true relationship. So correction for attenuation adjusts for this, estimating what correlation would be if both measures were perfectly reliable. Attenuation is the weakening or reduction. If measures are not perfectly reliable, then correlation appears weaker. This is just what's happening. So this is what happens, attenuation happens when our measures are not perfectly reliable and our correlation is weaker. So attenuation is caused by measurement error, and so sometimes the range of scores in a study is limited, and when only the high performer, I have given this example so many times, I'm sorry. So artificial reduce in correlation because of no variability is what we experience, and in return there's a range restriction correction estimates what correlation will be in full unrestricted population. In our meta-analysis is what we can do. So let's come to validity and decisions. So here you can see in this picture there are true positive, which these are the people that we want to hire. These are the people that are successful, and we have successfully found that these people are successful, right? These are the people that we do not want to hire because they did not do well on the test, and actually they did not do well on the test because they're not good, they're not going to be good employees for us. And there is this group which is very unlucky because wait, this is not a nice circle. I don't like this circle. So this group is actually, they would be good employees for us, but our test did not show them as good employees. And then we have true negatives, which are I'm sorry, I mixed it up. I'm sorry. Let's go through it again. So firstly, I said this correctly, that we have true positives, like the people that we want to hire. Then we have false negatives, like the people that we missed. These were actually good people. These were successful people. These were the people that we wanted to hire, but we could not successfully estimate their potential. And here we have true negatives, which are like the people that we actually don't want to hire because they're not as successful as we wish them to be. And then we have these people which are actually not very successful, but our test could not estimate that they were not good options for us. So this is basically what this means. Factors that affect outcomes of decisions, we have three factors. Firstly, validity, and secondly, base rates, and thirdly, selection ratios. So we will go through each one. Basically here you can see a low validity option and the high validity option. In the low validity option, we are not really sure, like we are only like 20% sure that we are making correct decision. But in the 80%, you can see that like we have captured the people that we want for the most part. Only a small part of successful employees we cannot see, but we can see the majority of them. And here we have a small portion that we will hire, although they are not successful employees. And then we have successfully found the people that we really don't want to hire because they're not successful. So here you can see how validity affects our decisions and how higher validity makes our decisions way more efficient and less risky. So base rate is basically like high versus low. Like if most candidates are already very qualified, there's not much risk of losing money, for example, because most of the candidates are good employees, good enough for us. But if most of them are bad employees, then we want to find the good candidates. We really need to find a good candidate so we would not lose a lot of money. So this is how high versus low base rate affects our decisions. And in selection ratios, we have number of open positions and number of applicants. And based on this, like it's basically how desperate we are for employees, right? Like if we are very desperate, we have to kind of take the cutoff point to the left. But if we are not very like we only need small portion of people, that means that most people will not get hired, and we are taking our cutoff point to the right part of the graph, right? So in utility, in terms of utility, it translates validities into economic gains or practical worth of a test. Utility of predictor first expressed in comparison to random selection. And then we have validity coefficient. Validity coefficient shows how well it predicts X. Like higher the validity, more accuracy, then we will have greater economic gains. Like for example, in the hiring example, we are hiring the correct people, so we are not wasting our money. We are making greater economical gains. And yeah, we can compare between like if we did no assessment versus assessment, is it making us gain money or lose money? So determining cutoff scores are threshold between positive and negative, like suitable for job or not. So where cutoff score is placed affects sensitivity and specificity. Like we are doing a trade-off. We have false positive versus false negatives. Like the people that we thought were suitable for us, but they are not actually suitable for us. And then there are people that are mischances, but we thought that they were not successful candidates, they were not good candidates, so we lost them. You can think of it like two negatives make a positive, but that positive is kind of like a secret, so we can see it. But this one is like negative in conclusion, so maybe it will help, I don't know. So yeah, like also we need to, when we are deciding for our cutoff score, where we're going to place it, like we can give the example of cancer treatment versus minor illness. Like when we are finding a treatment for cancer, we need to make sure that we are very careful. So our cutoff point most likely should be on the very right side, like here, because we want to make sure that we are making the correct decision. We want to make sure that we are not hiring the wrong employee or choosing the wrong drug for the patient and not damaging them. Or versus if there is a minor illness that doesn't affect anything, then maybe we can kind of focus on more options, and we can give a cutoff point on the more like the left side of the graph scale. Yeah. So sensitivity is the ability to correctly detect presence of reality, like how sensitive we are to detecting something that is there. And specificity is ability to correctly detect absence of something. And then I have some lab notes. These notes are including of all of these like 4 chapters we have talked about, and I think these are important, so we can go through them right now. I think there's only like 4 slides. Yeah. So percentile is how many people are equal or below your rank. So yeah, and this score is calculated based on like your score minus your mean and standard deviation, and this gives you your z-score. And standard error of measurement is about the specific like specific scores in a test. Reliability coefficients, for example, they are for different tests, and it's about the entire test. It's not about one single person's scores and where it likely is. It's not about that. It's about the reliability of the entire test, and it's not about a single person's score. Whereas SEM is for understanding individual scores. It tells us how much error there likely is in one person's score. It helps to estimate range in which person's true score probably falls. A person taking exam endlessly may get like different scores each time. And what do we need to tell by that? Like, what is their actual score? What is their true score? You might ask. And we can kind of calculate this based on SEM, and different scores each time is coming from distribution of error. So we can find SEM by like standard deviation, just multiply it with the deduction from like 1 to reliability. So this is the error, the amount of error that is going to be in our test, and we are multiplying it with standard deviation, and this gives us our SEM basically. And SEM behaves like standard deviations of measurement errors, and test scores follow normal distribution, like 68% of the time. True score is within 1% above or below 1 SEM above or below of the observed score. For example, in the 68% of the time, this is what we need to measure for 68% of the time. For 95, we need to measure 1.69 SEM, so we need to like multiply SEM with 1.96, and in the 99% of the time we need to multiply SEM with 2.58, and then we need to either deduct these points or like add these points to the to our test score, so we can get what we are getting is our confidence interval basically. So yeah, here is this simple like example. If you would like to look at it, you can stop the video right now, but I will go on because I think it's very easy and you can kind of like try this yourself. It's basic math, but like you need to try it yourself and you need to like kind of calculate it yourself. I think that will help much better than like me calculating it for you. So reliability, when it decreases, SEM increases. SEM is the obviously error, so our error will increase when our reliability is decreasing. To calculate SEM, we need to take into account measurement errors in test scores and standard deviation. So SEM is used to calculate confidence intervals, like person's true scores basically. So we have went through this basically for the entire class, but construct validity is the scale really measuring what it's supposed to measure, like we're just looking for that. And we can either use convergent validity or discriminant validity. In convergent validity, we are trying to assess same or highly similar constructs if they are strongly or moderately to strongly correlated with each other. So our instrument is effectively capturing our intended construct, and in discriminant validity we are measuring of different or somewhat related constructs that are weakly or weakly to moderately correlated with each other, so that our constructs that are theoretically distinct should not overlap. And here is an example from the slides. Here you can see the scale used for discriminant validity. There's low to moderate amount of overlap, and in the scale used for convergent validity, there is a high overlap. So that means that our study has construct validity. And here, as you can see, again, there is, in the discriminant validity, there is low to moderate, and in convergent validity, there is a very high overlap. So these are all my notes basically from the lab. Thank you for listening, and I hope this class was helpful to you, and I hope to see you in next class.